Hello, this is Mocha Product Manager Martin Brennand, and welcome to this tutorial on solving a 3D moving object by using multiple tracked layers. Let's dive right in. So today we're going to be looking at solving 3D moving objects, but in the context of clustering layers together to give Mocha as much information as possible. When you're solving for 3D, you want to be able to give the solver dimension information. So in the case of this car that we're going to solve, we have the back of the car and the side of the car. And if we only track the back of the car, we don't really have any ZYX information for the solver to really grasp what's going on. We might get lucky and the solver will figure out a nice way to work with a single plane. But ideally you want to be giving it a bit of depth, you want to be giving it a bit of rotation, and so on. So that's why we're going to cluster a couple of layers together in a single group. And this is what we're going to show you in here. Now we're inside Fusion, but once we're inside the Mocha Pro interface, it really doesn't matter what program you're using, whether it's Adobe After Effects or Premiere or Avid or whatever you want to use, or even the standalone. Once you're inside the Mocha Pro interface, the tutorial will be the same. So don't get thrown. If you're not using Fusion, you'll be fine. So I'm going to come in now and launch the Mocha UI. And here we are with the familiar Mocha Pro interface. So I'm going to scrub through and just see that shot is running smoothly. And the first thing we want to do is deal with the car itself. So I'm going to zoom in here a bit, and we're going to find some planes to work with. Now there's quite a big deep dip in the back of this ute here, so we want to avoid tracking that part. I'm going to come up to my X-Spline tool, and we're going to draw around this shape here. So let's just grab the whole plane of the back of that car. I'm going to avoid the reflection here on this bumper because that might throw us out a bit. And we'll just track all the way around like so. So we've got a fairly good set of information for this area here. So the reason we avoid these bumpers here is you can see how that sharp ground reflection is coming in the back of the bumper there. If we scrub through here, you can see quite a bit of change in information going on in that reflection, so we're going to avoid that. So next I'm going to turn on my surface tool up here, and we're just going to give it a bit of lining up here. So let's just pull it into the corners. If you want to see those corners a bit clearer, just come up to the magnifying tool, and then it'll come up in that top left corner there, and we can see where those corners are going approximately. So it doesn't have to be super accurate, this is just to line up so we can see the track a little bit easier and make sure it's tracking correctly in perspective. Alright, we've got that. We've got our matte. Now let's go ahead and track. Down in our motion parameters, our minimum percentage of pixels is pretty good already. It's about 90% of those pixels. And I'm going to turn on perspective because this shot is moving in perspective. And let's start tracking forwards. Just keep in mind throughout the tutorial I may stop or speed up parts which are a bit boring to watch, so let's track forwards and I'll see you after it's done. Alright, so that track is done now, so let's have a playback and see how this is looking. I'm just going to press Shift and 8 on my keyboard, which accesses the asterisk key, which will zoom everything out back into full view. And we're going to scrub through the shot and see how that track is looking. And that's pretty decent. If we can't really see what's going on too clearly, we can zoom in a little bit here, and I'm going to turn on my quick stabilize button, and then I can play this back, and everything will lock into place when we're zoomed in. So we can just see how well that's tracking. We can't see any drift going on here. It's turning nicely. So this will probably do for the back of the car. Yeah, that's looking pretty good. All right. The next thing we want to do is deal with the side of the car. Now we could go ahead and solve at this point, but we're not going to get any useful information. I want to get both sides of the car first, and then we can try a solve. So I'm going to call this one car back, and we'll just save our file. And now we're going to start drawing the next layer. So just to keep things clean, I'm going to hide that for the time being so we don't have to see it. And now let's draw the side of our car here. I'm going to zoom in a little bit closer to see what we're dealing with. Now again, you want to look at this and see where the planes of information are. So we've got this big mirror sticking out, so we don't want to draw over the top of that. And we also want to avoid the big shiny reflection in the window here. It may track okay, but this is something to look out for. Now the tyres are technically in plane with the rest of our shot here, but they do have quite a significant amount of rotation detail in the hub here. And when they're turning the corner, you can see that they also distort as the tyres turn. So we're going to try and avoid those as well. So let's come up to our X-Spline tool again. And I'm going to draw from the back here. I'm going to avoid those windows. I'm just going to get the little bit of edge of the window to get that plane. I'm going to avoid the mirror. And I am going to get the little black section here because that kind of stays consistent. We'll come down to about here where it curves down. Just going to get the edge of this area. And just up to the edges of this backlight. So that'll probably give us an okay plane. Let's just pull this in a little bit. Right. And we're going to do the same thing with the surface again. I'm going to just rotate it around so that it's basically in perspective. And once again, if we turn on the grid, it's much easier to see where that perspective is. So I might line it up with the front here, and I might line it up here with this door. And once again, you can adjust this before and after the track just to line it up a bit better. This isn't tied to the track in any way unless you're doing manual adjustments. All right, so we've got that. I'm going to call this car side. And once again, we're going to use perspective tracking, because again, this is going to turn in perspective. So we'll turn that on. And again, we're going to start tracking. Now, I've still got my little stabilized finger on here, so we'll be able to stay zoomed in as this tracks. So let's go ahead and track, and we'll see you after it's done. All right, so that one's tracked. So let's just scrub right back through the shot, and we'll see what we're dealing with here. And that's looking pretty good as well. We're getting a nice turn in perspective. There's no obvious drift. There's a little bit of drift, but we might be okay with that. We'll see how we go. We might need to adjust the track. But overall, I'm pretty happy with that. Okay, so now we have the two sides of our car, we can start to look at doing a camera solve. There's going to be a few other things that we need to do though, as you'll see. So I'm going to turn off the track for that one. Let's turn on the visibility of both. And then I'm going to select both my car side and my car back, and I'm going to put them inside a group. And I'm just going to call this one car. I suppose we could call it ute, which is the Australian term for a truck, but let's just stick with car to make it easy and generic. All right, so I'm going to zoom out, and let's have a look at, let's turn our grid off, and we'll go over to camera solve. Now, before we go any further, there is a few other things that we need to do to make sure this solve works correctly. One, we've tracked the back and the side of this car, but the car itself is still one big moving object inside the scene, and we want to be able to avoid the solver trying to solve those moving pixels. So we need to create a mask around it. So I'm going to come in here and draw a very basic mask around it. I'm going to go all the way around. And this is just to tell the solver, don't consider these pixels when you're doing the camera solve. So I've got a nice loose mask. It doesn't have to be super accurate. This is just a garbage mask. And then I'm going to link this to my other track layers. So let's call this one car mask. And then under link to track, I'm going to use the car back. So we're going to scrub through this shot. It's going to start moving, and obviously it's going to distort a little bit because it's not entirely perpendicular to that matte. So we're going to have to adjust a little bit as it turns the corner. But we'll quickly go through and just find the areas that matter. and that will do fine. Now, we could have used the object brush and the matte assist ML to generate the matte around the car, but it's a bit of overkill for this particular shot because it's such a basic shape. So let's just zoom out, and we'll scrub through and just make sure that's covering every frame. And that's looking pretty good, so we don't need to worry about that now. So let's just save again. Now finally, we do have a lot of distant sky here, and this is going to cause a problem when we are trying to solve this shot, because very, very far away trackers can cause issues with the solve. So there's a number of ways we can do this. We can just do a basic shape, or we can do a matte assist ML matte to try and just get this edge here, but I kind of want to capture these trees. So the first thing I might do is just do a basic matte around the sky area. So let's just again grab a nice big X-spline. We're going to draw a huge shape here. And I'm just going to cut off the tops of the trees. I don't particularly care about the tops because it'll still give me some nice data. We'll go around this big one because it's a nice one. And we'll do about there. And we'll just go ahead and track this. So I'm going to call this one Sky Mask. We'll track it in perspective. Perspective's probably overkill, but we'll do it anyway. And I'll track forwards. Alright, so that's tracked, and we're going to have to do a couple of hand adjustments here. So we could have also done this by hand, but I'm just showing you a few different ways we can approach this. You can track it, you could use the object brush, you could just hand animate it, but the idea is just to get a general mask of the sky. And we're not being too fussy about the tips here. If we're having trouble with the solve, we would refine this down a little bit further, but we're just doing a rough mask here for the time being. Alright, so let's just, I'm going to turn off my quick stabilize so we can see this. To move this around, I'm just going to smooth that out a bit. I'd like to capture that tree. This tree can actually go, that's fine. So we're going to go through the shot here. You can see it needs to be adjusted to capture this tree a bit. That's all fine. And then we can hide the rest of that. There we go. And that should probably do. Now, to keep things tidy, I'm also going to put these two inside a folder. So let's go with that, and I'm going to call them masks. Now, importantly, I'm going to put the masks at the bottom because these are solving masks, they're not tracking masks. So we're going to throw them down the bottom just in case we want to do any other tracking later. So we've got our sky mask, and we've got our car mask. And then we have our car side and our car back. So now we can go over to the camera solve module and start solving. So here inside the camera solver, there's a few things we want to do to our layers. We've got a moving object group here in the layer properties, and we have masking properties. Now for the masks, we want to be able to mask them. So I'm going to set all these to mask. Inside the moving object group, you have to be a little bit more particular. For the first part, you need to absolutely make sure that the group is set to moving. If you don't set it to moving, it won't work, because what we're doing here is we're saying this whole group is a single object. If you have, say for example, these not set to moving, it won't work. So for example, if I click solve, we're going to get a warning that says it contains layers that aren't moving, so it's not going to solve. And the same goes if we take a moving object out of that group. Let's just take that to moving and that to moving. We click solve. It's going to say there's too many moving objects to solve right now, because at the moment Mocha does only solve one moving object at a time. So I'm going to move that back in. Now we have a car moving object with two tracked moving objects inside of it. And we're just telling Mocha again, just to hammer this point home, that everything inside this group is part of the same object. And then it's much easier for it to solve calculating those different dimensions we tracked in the side and the back. Now secondly, we want to change a few parameters here. We've got 190 frames. Generally, The max track count of 120 would be enough. I'm just going to double that just to give it a bit more space to breathe. And everything else should be fine. It's not on a tripod, there's no zoom lens, we're not using corners. So we can go ahead and try and solve this now. Moving objects and everything else is masked. So we'll go ahead and solve. Alright, and now we have our solved shot. We can see we've got a moving object over here, and we've got a pretty good solve rate of 0.7. We can see what the two values are by going into the solve output. We can see the camera solved at 0.6, which is very good, and we can see that the object also solved at about 0.7. So that's a really good result for our object. Now there's also, again, now we've done the solve, there's going to be a few things we need to do to set this up correctly. So I'm going to come down here, for example, I'm going to click this point just behind the car, and I'm going to make that the origin of my scene, so it's right in the middle. So let's click Make Origin, and we can see our grid going in place. If you can't quite see that, let's just turn off the background for a second. There's our point. And I'm also going to align this to the overall road area. Now, you've got to be careful here, because if I just select these points here, so let's just hold down Shift and grab all these points, this looks like I'm aligning to this ground area here. But if we scrub the shot, you're going to see that some of these points are actually way over here. So we don't want to align that. So it's always good to just check your shot before you start checking any align points. So I'm going to grab this person here, this dot, this dot, this dot, and this dot, and maybe this one back here, and click Align to Ground for that one. And that's giving me a much better result. So we can see that's nicely lined up. We've got a straight line and it's sitting correctly on the road. Now the second thing is a quirk of moving objects, which is, while this looks correct in camera, it may not actually be sitting correctly in the scene. So I'm going to hold down my Alt or Option key and just drag, and you can see that the car is actually sitting below the road. So that's a problem, and we can fix this relatively easily. So I'm going to go back to my camera. What we want to do is, in our 3D objects over on the right hand panel, we're going to go into Layers, we'll select our car, and then I'm going to move over to the left view. Now keep in mind, we made this origin point right next to the back of the car, and I did that on purpose. I'm going to go into my left view, and we can see that car sitting way below the line here. What we want to do is essentially bring it back to not just above where these road lines are, but straight to where this surface will hit the y-axis here. And we use the object projection tool for this. So what we do is we just drag it down to reduce its size, which also moves it in space. So that's about there. Let's just zoom in and check. Could probably be a little bit closer. And you can see here the object projection has actually jumped back to 100. This is a permanent change to the object, so it's not a relative change, which is why it jumps back to 100%. It's just a tool to realign, but we do correct the transformation afterwards. So I'm going to scale it up a little bit, and about there is probably good, because you've got to remember we've tracked the back points here, and there'd be wheels on the ground, which is this ground plane here. So if we now go back into our camera view, you'll see that nothing's changed in the projection, and this is by design. We've actually made it so that when you adjust any moving objects in space, they're scaling correctly to match the correct camera projection. So if we scrub through and have a look at this, we can see that's now lined up correctly and rolling down the road quite nicely. Now if I do my Alt drag again, we can now see it sitting in the right spot. So if we scrub through, you can see, even as it goes over that little ridge there, you can see the little bump happening, and it's solved nicely. So we can keep tweaking this, we can have a look around and see what else we could do to it, but ultimately now what we want to do is get that data out. Now this is the big change between what version of host you're working with when working with Mocha Pro. Everything up to this point, it's all been Mocha. So whatever you're doing in your host will be different depending on what we export. So in this case, I'm exporting to Fusion. So I'm going to choose a file format that's best for Fusion. And I'm going to come into Export Camera Data. And we have a number of options here. Now, obviously, we can't export After Effects data, but we could export FBX. We could also export USD, or we could export Alembic. And it really does depend on your individual preference, what you prefer using in your 3D environment. For Fusion, I tend to prefer using FBX data. And the reason for this is it generates better point clouds for doing the general scenery. So I'm going to change a couple of things here. Up here, we've got export all objects. I don't actually want all objects. I really don't care about these distant objects over here. So I'm going to scrub through my timeline. And this is a bit different to what you would be used to in earlier versions of Mocha, where anytime you had to do any exports, you had to close the export dialog to make changes. In version 2025, you can keep the export dialog open as you're making changes. So I'm going to select these points here, and say I don't really need these. So I'm going to invert that selection, and I'm going to say only export the selected, which will be everything else. I'm going to export all the feature points. I'm going to export the mesh faces for my surfaces, and I'm not going to bake the scene transform because I like to keep the hierarchy. And finally, you've got the option to export these individual points as meshes or as nulls. And in Fusion's case, I much prefer using nulls, because if you export individual meshes, you're going to get a node for every single mesh, and that's a lot of points, so we don't want to deal with that. So let's go ahead and export that. I'm going to save it to disk. We'll call this car001. And now we can close and save. And we're back in Fusion. So now let's have a look at how we set up in a host like Fusion. I'm going to drag this up a little bit. We'll move Mocha Pro over here because Mocha's work is done for the time being. And the next thing I want to do is import my FBX scene. Now, I don't recommend just dragging it in. What you should use is in File, Import, FBX scene. And we're going to grab our car model, and here's where we need to make sure everything is lining up correctly. First of all, just keep everything here at the default. They're all good. We want to check to make sure that the FPS is the same as our frames inside Mocha, which it is. This is 30. And we want to make sure that resampling rate is exactly the same. You don't want to mess around with the keyframes. Speaking of messing around with keyframes, make sure this option is turned off. You don't want to remove any duplicate keyframes, because what Fusion calls duplicate is actually a threshold of difference. So if there's any subtle changes in your keyframes, they may get removed by this option. So it's best to keep that turned off. And finally, we want to merge it into the existing document. So let's go ahead and click OK. And we get this nice big tree. So what we've got here is we have our moving car with the two different meshes inside it. We've got the camera, and we have a point cloud. And these are all going back into scenes, and then they're all merging together into a single scene. So let's just split our view for a second, and we'll drag that in. And I'm going to right click this little perspective line down here, and we'll go to Mocha camera node, and we can see that shot now. So let's play that back. We're seeing them lining up as expected. So there's, again, a few things you want to do if you want to be able to merge these things into the render. So I'm going to, first of all, set up my render node. I'm going to press Shift Space and type in Renderer 3D. We'll drag that into there. And then we're going to merge it over the top of our footage. So we'll grab a merge node. We'll grab the background, which is our source. And we'll grab the foreground, which is our render. And let's have a look at that in the scene. So what you'll see immediately is something doesn't look right. And this is because Renderer 3D defaults to a couple of base settings. So we'll go into Renderer 3D. First of all, you want to change the renderer type to a hardware renderer. You have to use hardware renderer if you want to see your point clouds, and we'll change some things in point clouds in a second. Secondly, we want to go to the image and actually change it to the correct dimensions. By default, it's actually always set to HD, which is not what you want. Here, we're using a UHD shot, so we need to change it here. So I'm going to change this to 3840 by 2160. And now we'll see those points lining up to the car. Secondly, we go into point cloud, and we actually check make renderable. And now you can start to see some points tearing up. They're quite small in this shot, so we will make them bigger. I'm going to make them yellow for a start, to make them stand out against the snow. We'll change them to points, which are clearer, and I'm going to change it up a little bit to about there, and now you can see it much clearer in the scene what's going on. So if we play this back now, we can see our surface is running along with our car, and our scenery is lining up correctly in the shot. So finally, how do we actually work with this data? We've got scene data, we can place 3D objects in. If you want to actually connect an object to our moving data, thankfully the FBX scene sets this up in a way that makes it very, very easy for you. So I'm going to do a basic cube in this instance. We're going to go and press again Shift Space, and I'm going to type in cube, and we'll grab cube 3D. And by default, you won't see it until you add it to the scene. So let's have a look here. We're going to add it to the scene. There it is. That's not going to do anything at the moment. It's just going to move with the camera. You can see it's actually sitting in the space correctly and moving around. But we want it to move with the 3D object. So to do that, we're going to disconnect that. And it's as simple as actually just adding it to the car node. So now, if we just zoom in here, and we're going to scale it up so we can see what's going on. Transform. Let's make its size a lot bigger. There we go. And by default, it's going to be attached to that car now. So if I play back, we can see now it's moving along with the car. So this is very, very convenient because it means you don't have to do any other snapping or things. It's just literally merged into the same car scene, which has all the moving object transform data attached to it. So then we can go ahead and line this up correctly. So if I go into my transform now, I can start rotating it. I'd probably do this in a different view. Let's have a look at left view, for example. We'll zoom out here a bit. We'll move that up a bit to put it in the bed. Then we'll rotate it a bit. That's looking okay there. Make sure it's fitting into the right spot. And it'll take a little bit to just get this into the right spot. Let's go over to our top view. So we want to move that back. Maybe the scale is just a little bit big, so we'll go back to the control here and zoom it down a little bit. That's getting pretty close. So now we can go ahead and play that back, and we can see it moving along correctly in the shot. Now, the final thing you'd want to do here is actually mask out your object. Luckily, we have already some masking done inside Mocha Pro, so you could actually add another merge here. If I go and look at Mocha here for a second, and we go to Matte, Apply Matte, we've got a whole bunch of masks here already. You may need to add some more refined masks here, but let's see what we can do with the existing shots. I'm just going to turn off my sky mask and my car mask here. So we've got a few useful bed information here. So let's grab another merge node. We want this to be the foreground. And we want this one to be the background. And we can see now that that's sitting in the right spot. We don't really need our surface meshes anymore. So if we come down to the car back surface, I can press D and D to hide those. And then we can start playing that back, and we'll see it's actually masked behind the car. Not a great mask by any means. I'd have to go back in and refine that mask, but you can start to see how the compositing works for these shots. So that's how you solve 3D moving objects as groups inside Mocha Pro and get that data out to Fusion. Let's just quickly take a look at our more fun but complicated example using tracking a head. So in this particular shot, I've got a set of masks to cover any moving objects I don't care about in the scene. And I've also got a head track here. So you can see I tracked the front of the head using a mesh, and I tracked the side of the head also using a mesh. And they're once again inside a head group. We've got the focal actor, who has been masked out using the object brush and Mattassist ML. We've got the right and the left guy here, also that have been matted out with the Mattassist ML. And then finally, I've just hand-tracked a bagpipe guy in the background because he was very, very easy to track without needing any additional masking. And I've chosen to ignore these guys in the background because they don't move all that much and the solver just discards those points. So we can see here, the track of the head is, again, we're using the dimension of the turning of her head as she's pointing, and a little bit of the front. We might have gotten away with a whole mesh here, but there really is two different perspective levels here, so I wanted to be sure. So there and there. So now that we have these two, we can go ahead and solve. So in the solve here, if we look at the 3D, we can see we've got a pretty good solve of the 3D object here. And if we look inside the 3D view and play that back, we can see her head's turning quite nicely. We're getting the whole kind of skull area very, very cleanly. And we've got the table in the front here if we look at the camera. And that's our origin point since we couldn't find any flaw. But then we can go ahead and use this in something like Maya or After Effects. In this case, I chose to use Alembic, and then I brought it out to Maya and parented in some information. So let's have a look at that. Over in Maya, you can see here that I've got the same scene, and I've parented some horns to the 3D object where my moving object is. And I've just parented it straight in to the scene as before. It's very similar to how we did it in Fusion. All you do is you select your 3D object and you apply it to the scene where the moving head is, right there, and then that gives you an attachment to the area that you expect. So we've got the mesh here, and the horns are actually moving with the overall transform as expected. So that wraps up this tutorial on clustering layers together to solve single moving objects. If you've got any questions or want more information and tutorials, go check out the website at borisfx.com. Thanks very much, and goodbye.